Braking technology has changed a lot in the last few years, and today I'm just going to show you a couple of new things and compare them against the old technology. We've got a surface transforms rotor here, which is what I would consider the current technology premium braking rotor. We've got a Porsche steel rotor that's got an aluminium hat. This is the current Porsche ceramic rotor that's available with the cars. So first up, let's look at the weights. The old scales, Porsche ceramic rotor, 7 kilos, close enough, 6.8. Surface transforms, 6.6, very similar. Porsche steel rotor for the same job, 12.4. So what does that mean? The most important spot, I think most people would agree with me, to remove any weight out of a car is out of unsprung mass. So parts of the car that are on the suspension. And even more important to unsprung is rotating unsprung mass. So the rotors travel with the wheels, and every time you accelerate the car and decelerate under brakes, it takes power. The lighter the rotor, the more power you end up using to move the car. So that's one critical thing. Following that, as the wheel has to follow the bumps on the road, the lighter the rotor, the better it will follow the bumps, the less work the shock has to do, and the ratio of body weight to unsprung is better. So the best place to remove weight from a car to gain the most performance is either the wheel, the hub, or the rotor. And the rotor weighs a lot, as we've just seen, the steel rotors weigh a lot. So both the surface transforms and the Porsche ceramic, they're almost the same weight, but technology-wise, they're significantly different. So we'll look at that. So something I want to look at with the Porsche factory rotor, and the significant thing here is the minimum weight. So you've got a minimum weight for each rotor. Why that is significant is because most people will be used to a steel rotor that gets thinner as you use it, and they run out of thickness. A ceramic rotor doesn't get thinner when you use it, it stays the same. So it's not because they wear out physically. What happens is, when they get to 1000 degrees centigrade, under extreme braking, a chemical reaction takes place and the rotor oxidizes. When it oxidizes, part of the chemical reaction, it gases off, so it loses weight through being hot and through chemical reaction. Once it loses weight, it becomes less dense, and it doesn't conduct heat as well, and it also is more brittle. So the surface will pop little craters out of the surface. So they're quite prone, when they're used in extreme circumstances on the track, to get to 1000 degrees, to become light and brittle, and then to pop the surface of the rotor away. So that's their downside. On the road, they'll last hundreds of thousands of kilometres, and they're a great thing, no dust, all that sort of stuff. On the track, that's what happens to them. Part of that is because they're made by, let's say, crunching up lots of carbon fibre into little rice granules, little bits, and they push it together into a mould. And that's how these are made. So conversely, the surface transforms rotors are made in a different way. There is no minimum weight. And the reason for that is these run a lot cooler, so they don't get to 1000 degrees as often. That's not their downfall. These are made by, they call it long chain technology. I guess it's layers and layers of the ceramic material put on top of each other and then pressed together, which leaves all those fibres long. So the fibres go from the inside outside. And what that does is, it does two things. The most important thing is it transfers heat to the inside, so you don't end up with the surface being really hot and the inside being cold. So they transmit heat from the inside, from the outside to the inside better. The other thing is, because they're long chain technology, they're physically stronger. So they're less likely to pop craters out. They're less likely to be damaged if you drop them. They're physically a lot stronger. The old ceramic rotors have a bit of a bad rep from people touching them with wheels and things like that, and them physically breaking in half. Doesn't happen with these. So these are physically a lot stronger as well. So our experience is that customers that have got very fast cars, let's say a GT2 RS or something like that, really quick cars that do a lot of track work that are fast, steel rotors, you might get 5 or 6 days out of them, track days out of running them. The Porsche rotors, maybe the same, maybe less, depending on how they're being used. They don't deal with really extreme use. One client who's got a very fast car, 48 days, track days, out of one of these sets of rotors, the Service Transforms rotors. So significantly more. I mean, quite amazing. So they're expensive. I mean, they're all expensive, you know. The Service Transforms are typically about half the cost of the OEM. Still not free, but when you do the sums and look at how long they last, they're fantastic. Yeah. Back to the steel rotor. This is one that was on the shelf. They wear out physically, so they get thinner. Really, the problem ends up being that you get cracks from the holes. So Porsche have a few guidelines with regard to that. These particular ones don't have holes that go right through on the edge. These ones will go right through, but the edge ones don't. Any hole that reaches the edge of a rotor means the rotor's no good. Anytime the two holes get cracks between them and they join, it's no good. Or anytime the crack is longer than 7 millimeters, I think, on any of these holes, it's no good. And you'll typically find on a fast car that's 5 or 6 days use. Yeah, not very much. So in conclusion, the Service Transforms rotors, in my opinion, best technology available and well worth the effort, and putting them on, you won't be disappointed. Lower temperatures, longer life, better feel, better handling, better acceleration, no downside. I'm Richard from PR Technology. I'll see you next time.